Good morning, FOR 242. It is time to go and access a larger LiDAR data set through the NOAA Data Access Viewer. So search NOAA LiDAR coast.noaa.gov, click the top link, and go to elevation/LiDAR. Zoom in on the area of your stands, the area you've been working in already. Use the satellite image here to navigate. You may need to go into QGIS and look at your own stands at this scale. Zoom all the way out so you can see the lakes, and then use that to navigate into where you want to be. I know I'm going right here, so that's where I've been working. And I want this area here. I'm going to draw, so click the draw button, then click, hold, drag, release a box around the area of interest. That is going to give you an option here. Click here, and then add to cart. And just like before, add to cart twice. This is going to look at just under 500,000 points, and once you get past 1 billion, it seems to stop letting you do this. So I don't know if that's just it won't do it during busy times thing, or that's its cutoff, but this size I think is no bigger than anything you've got for your stand, so this should work for you. So 2 in cart, so add to cart twice, 2 items in the cart, and next. Just like before, we changed the projection to UTM and scroll down here, and for 1 we want the average of the ground, and again I'm going to use a 2-meter grid size that speeds things up, and we keep most of what we need in terms of resolution. When you're doing a stream delineation model, you do want a 1-meter grid size for your ground elevation. That's where it becomes important, but for right now we're good with this for a canopy data set. So again, grid size 2, that's a 2-meter by 2-meter grid, about 6 feet by 6 feet, and it's going to average the elevation of all the ground points within that grid. Now for the next one, number 2, change to UTM, and we're going to want to change that grid method to maximum, grid size 2, and data classes all. And that looks at the highest return, so the first highest point of elevation that laser scanner encounters at the canopy of a tree, that's what's going to be represented in that 2-meter grid cell. Then the elevation of that cell is going to be subtracted, leaving the height of the tree. So, next, give it the email, hit next, confirm 2 meters, 2 meters, ground, all, UTM, UTM, we are all good to go, submit. Hurry up and wait. And now, half an hour later, we have our download links for the digital elevation model in this email and the digital surface model in a second email. You'll see if you scroll down, we have these different TIFF files that we'll have to stitch together. So go ahead and download that. Once that downloads, we'll go ahead and extract it. So I'm going to click on that. That's going to load in here. I'm going to extract all, browse to a location. And I'm going to place this in a new folder here. And this is going to go into Thomson Stands CHM. And within that, I'm going to make 2 new folders, one for the DSM and one for the DEM. And that'll make sense in a moment why these have to go into 2 separate folders. The reason why, I'll give away the ending, is that I'm going to point the software at the folder and not each one of these individual files. So now I'm going to do the same thing again for the other zipped file. So here's the last demo I did that was all just one file. So we have one intermediate step, or actually one intermediate step times 2, and that is raster, miscellaneous, merge. At the top, the input layers, hit the 3 dots here, and from there, add directory. Click once. I'm going to select my DSM first, select that folder, and it's brought all those in, and I want all of them except that XML at the end. Now I've got to hit OK, not anything else, OK. I'm going to keep all of the other defaults, go down here, save to a temporary file as it defaults to, and run. Run, looking at all those different TIFF files, stitching them together, close. Now I can right click and zoom to layer. And that is exactly as it should be. I'm going to right click on that, rename the layer and call that DEM. So that's the smooth one. The rough one will be the DSM that includes the canopy heights on top of the ground elevation. Under raster, Miscellaneous, Merge, then select the inputs, Add Directory, and I mixed this up before, so my DSM is living in my DEM folder, my DEM is living in my DSM folder, that's fine. So double click on that and select folder, uncheck that XML and OK. And now, confirm, save to a temporary file, everything looks good, run. Think. Close, and now you can see that roughness. That's the height of the canopy on top of the height of the ground returns. So like before, we're going to right click and rename that layer, and I'm going to call that DSM stands. And likewise, I'm going to rename this one, rename layer DEM underscore stands, because I already have DEM and DSM in here, I don't want to confuse myself. And that takes us back to where we were before. So we have two TIFF files, two raster files, one elevation model, one surface model, where surface is the top return and elevation model here is the ground return. And like before, raster, raster calculator, DSM minus DEM. Now it needs an output layer name here, and I'm going to plot that in my FOR 242 datasets, week number 7, as CHM rough, because there's some issues we're going to need to correct with this that come from having a river running through it. Okay, and there, that's what you want to see actually. So the reason why is there's some returns or lack of returns off this river, and that's causing some issues because this is about 1,000 feet in elevation, but on the river sometimes there's 0 because there's just no return there. So you have a 1,000 feet difference here. In a moment we'll write an expression to sort of filter out those values that are most likely in error, the ones that are 1,000, 1,300 feet off the ground, or the ones that are below 0. But for right now, we want to visualize the data set. So double click on CHM rough, and I'm going to change this to a single band pseudo color. And here where we have a min and a max, I'm going to make the minimum 0 and the maximum 150, the height of a very tall white pine. And now, okay, so that's filtered out anything outside of that range. We're only seeing from 0 to 150 feet, and that gives us a pretty good look at our canopies. And looking over here, we can see this is after the most recent operations in this area that we know about, so that's good. This is as up-to-date gets. But you can already imagine how different that stand delineation and stand typing would be with this data set in hand. It's a very different image. So that looks pretty good, but if we look in here, we can see that's our little flooded area there. I think the beaver plugged up a culvert, and let's see how tall that thinks it is. Yeah, that thinks it's a 1,095 feet tall, so we've got to correct that in the data set. That won't do. Here's our documentation for QGIS showing what we're about to do. So we're going to take our, in this case, canopy height model, and where the canopy height model is greater than or equal to 0, this expression is going to set that cell's value to 1. And then that 1 gets multiplied by the canopy height model. So 1 times whatever that happens to be returns whatever that happens to be. The other side of the coin, if it's not greater than or equal to 0, if it's negative, then it'll return a 0. And that will mean that 0 times whatever it happens to be will be 0. Into the raster calculator. Raster calculator. And we need the CHM rough. And that needs to be inside of parentheses, and we need to say greater than or equal to 0, close parentheses, times itself. The expression is valid. Now it needs a name and a location. So I'm going to plot that in my discard folder, and that's going to be CHM rough over 0. The next step is going to be to filter out the high values. So, okay. Zooming out, we can see the output is just like before. Let's go ahead and modify that just like we did before with a single band pseudo color. Classify that. You see, we only go down to 0 now, but we still have all these high values. Let's apply that, and now we have to ask the question, what is our highest high value? Let's change that to 150 and see if anything seems to be awry. Apply. Okay. And in this area here, it looks like we have some nice tall white pine. Let's look for the tallest of them. And I've camped out right here. This is a very nice spot. So these are some of the biggest and tallest white pine that you're going to get. Here's some photos from that spot. Completely forgot I camped out right there, but these are some very nice big white pine. And yeah, that's prop for scale there. Big tree, big tree, big tree, big split on big tree, rotten big tree, and big old downwardy debris. And I think that's a different spot. Yeah, different spot, big white pine, lots of big holes in it. In any case, these are very tall trees, and that's where I was taking pictures of the very large ones. And let's see, how tall are the tallest ones here? 137, 134, 136. So I think 150 feet is a pretty good cutoff there. There might be something taller than these very tall trees, but I don't see them anywhere on this map. So let's go ahead and write that second expression. So raster calculator, and this time we want to use the rough over 0, add our parentheses, and then here, and this time it needs to be less than or equal to 150. Close parentheses and then multiply by itself. So this is giving anything with a value under 150 feet a value of 1 and then multiplying that value by itself. So that way the value stays. If it's greater than 150 feet, it gets a value of 0. 0 multiplied by itself returns 0. So now we just need a name again, and we'll call this one, we'll put this in our actual folder now. And FOR 242, week 7, CHM stands clean. Save, OK. And now we have a cleaned up canopy height model. That displays in black and white just like it should, but let's change these min-max value settings and statistics to updated canvas, apply. And now wherever we go, we see the highest and the lowest values, highest being white, lowest being black. But that is not my favorite way to look at these data sets. Right-click, Properties. Instead of single band gray, single band pseudo color, I like this default color ramp. Classify that, apply. And we can go one step farther into the min-max value settings and use the updated canvas for the statistics event, which is what it uses to say this is the highest, this is the lowest. So looking at it zoomed all the way out, we can see this, but then let's go ahead and zoom in here. Investigate this patch of tall trees. What's going on here? Seems to be out of reach of both of these operations. What's going on? Question, is that height due to particular fertility of the site? Is it particularly high age? Is that something deliberately left as a reserve patch, which would be a valid thing to do? It's effectively a patch of forest interior because this will grow up and grow in. This is already filling in quite well. Let's investigate the height of that. That's 34 feet in height. So this could be a very nice patch of forest interior, meaning it's far away from any gaps, natural or otherwise, except maybe that little patch there, which looks like it might be a pond or something. But that could be left for the express purpose of some kind of wildlife species that prefers an interior habitat. Zooming over here, we can see the size of these canopies is very much larger than the size of these, and we can see a stark difference in the height between this band and the surrounding area. So you can see, to the extent that this data set is up to date, you can get a tremendous amount of detail out of it. Here we can see what look like the same skid trails, but there's some difference in prescription here, where tall trees are left here, some sort of a tall reserve, maybe a pine here, and in here, this is a younger, shorter, regenerating cohort. Likewise here, younger still, reserve tree, most likely pine. And we can see the difference in activity right along the river here. If we use our measuring tool, we can click once to start, double click to stop, right click to end that segment, change it to feet. That first segment, 280 feet, exceeding the 250 foot buffer, where the regulations I think said maximum 40% removal over a 10-year period. And here's something I've been looking for. This is a natural body of water without any recent harvesting around it, showing the difference in the height of trees around that water. With a gentle slope here, there's going to be a very shallow depth of water table, meaning a very small rooting volume for these trees to dig into. That means they can't grow so fast. And likewise here, some activity around, but going from shorter vegetation to taller vegetation as you go up that hill. So now off you go to find canopy height data for the location of your stands.